Okay, in this video I'm going to begin chapter 14. Chapter 14 is the last chapter that we're going to do for the course. So the main topic here in chapter 14 is that we're going to talk about graph theory. 14.1 says that is where we're going to start here. A graph is a collection of vertices, at least one, and edges. Each edge goes from a vertex to a vertex. Okay. Another definition, the number of edges joining a vertex is called the degree of the vertex. Okay. Problem 1, consider the graph. Okay, we've got this graph shown. How many vertices does the graph have? Okay, well, if I count the vertices here, here's 1, 2, 3, 4, 5 vertices. Okay, find the degree of each vertex. Well, vertex A has 1, 2, 3. So the degree is the number of edges joining the vertex. Okay, so the degree of A would be 3. The degree of B would also be 3. The degree of C is 2. The degree of D is 2. And the degree of E would be 4. Okay, how many edges does the graph have? Well, let's see here. So if I count the number of edges, 1, 2, 3, 4, 5, 6, 7. Okay. Part D, add the degrees of the vertices from the graph and write the sum. Okay, so let me do that. 3 plus 3 is 6, plus 2 plus 2 is 10, plus 4 is 14. Okay. What relationship do you notice between the sum of the degrees, 14, and the number of edges? So there's 7 edges, and the sum of the degrees is 14. The sum of the degrees of the vertices equals twice the number of edges. This is true for any graph. Okay. A definition there. Two graphs are isomorphic if there is a one-to-one matching between vertices of the two graphs, with the property that whenever an edge between the two vertices of either one of the graphs, there is an edge between the corresponding vertices of the other graph. Okay, so essentially you're working with the same graph in isomorphism. Okay, so problem 2, two graphs, which we'll call G1 and G2, are given. Determine whether the two graphs are isomorphic. If they are, show a matching between the vertices, and be sure to include any side work to further clarify the matching that you make. If they're not, just a quick explanation as to why it's not. Okay, so is G1 isomorphic to G2? Well, G1 and G2 have the same number of edges, so that's 5 edges, and the same number of vertices, 4 vertices, and each vertex has a degree 2 or degree 3. Okay, so we must now build an isomorphism. Okay, well, if you take G2 and pull vertex 4 up, then here would be the new graph. Okay, now notice how this graph looks very, very much like the original graph. Okay, so these two graphs are going to be isomorphic, and here's a matching that I've made. Okay, so G1, I'm going to have vertex A go to vertex 3, vertex B is going to go to vertex 4, vertex C is going to go to vertex 2, and vertex D is going to go to vertex 1. Okay, now there might be more isomorphisms. Okay, we're not saying that this is the only one. Okay, it's just we found a matching. Okay. Problem 3, two graphs G1 and G2 are given. Determine whether the two graphs are isomorphic. If they are, show a matching between their vertices, and be sure to include any side work to further clarify the matching that you make. If they're not, just a quick explanation as to why they're not. Okay, well, these two graphs are not going to be isomorphic. The reason is because G2 has vertices with degree 3. So here's vertex 1 has 3 edges joining it. Vertex 4 has 3 edges joining it. Okay, so those would be degree 3 vertices. And G1, if you notice, G1 has no degree 3 vertices. So, so there's no matter what we do, there's not going to be an isomorphism. Okay, so here's a degree 2, degree 2, degree 2, degree 4, degree 4, and degree 4. Okay, so yeah, the G1 and G2 are not going to be isomorphic. Problem 4, two graphs G1 and G2 are given. Determine whether the two graphs are isomorphic. If they are, show a matching between their vertices, and be sure to include any side work to further clarify the matching that you make. If they're not, explain why not. Okay, so here's G1 and here's G2. In G2, if we pull vertices 1, 2, 3, and 4 inside, or no, I guess outside of vertices 5, 6, 7, and 8, then you can see that what I've got here looks very much like what I have in G1. Okay, so I'm going to say yes, they're isomorphic, and the matching then, here's G1 and G2. So vertex A is going to go to vertex 2, okay. Vertex B is going to go to vertex 3. Vertex C is going to go to vertex 4. Vertex D is going to go to vertex 1. Okay, vertex E is going to go to vertex 6. Vertex F is going to go to vertex 7. And vertex G is going to go to vertex 5. Vertex H is going to go to vertex 8. Okay, so this would be one matching that we could make out of a few matchings. Okay, all we need is one matching for the two graphs to be isomorphic. Okay, so, and again, isomorphic means that essentially you're working with the same graph. It's just been changed up, but if you can easily change it back. Okay. Problem 5, two graphs G1 and G2 are given. Determine whether the two graphs are isomorphic. If they are, show a matching between their vertices, and be sure to include any side work to further clarify the matching that you make. If they're not, just a quick explanation as to why it's not. Okay, so here's the first graph, G1, and here's the second graph, G2. Now, in an isomorphism, triangles have to be sent to triangles, squares have to be sent to squares, rectangles have to be sent to rectangles, etc. Okay, so this is not isomorphic. The reason is because G2 contains a triangle, which is triangle 1, 3, 6. You can see that triangle that I've made there. And G1 contains no triangles. Okay, so no matter what I do with G1, I'm not going to be able to form a triangle there. Okay, so there wouldn't be an isomorphism. Okay, and by the way, that's true about any isomorphism. It means that triangles have to be sent to triangles, rectangles have to be sent to rectangles, pentagons have to be sent to pentagons, etc. Okay. Definition: a graph is connected if we can move from each vertex of the graph to every other vertex of the graph along the edges of the graph. The connected pieces of a graph are called components of the graph. Okay, so problem 6. We got two graphs, G1 and G2. Determine if each graph is connected or disconnected, and then determine how many components are in each graph. Okay, so G1 would be connected, since you can go from any vertex to any other vertex, and there'd be one component. G2 is disconnected, okay, since like there's no way to go from here over here unless you don't follow an edge. There'd be let's see, 1, 2, and 3 components. Okay. Problem 7. In any graph, the sum of the degrees of the vertices equals twice the number of edges. Okay, suppose that a graph has 8 vertices, 2 of degree 1, 3 of degree 2, 1 of degree 3, and 1 of degree 5, and 1 of degree 6. How many edges does this graph have? Okay, well, so 2 of degree 1. So I'm going to add up the edges here. Excuse me, I'm going to add up the vertices, the degrees of each vertex. So 2 have a degree 1, okay, 3 have degree 2, and 1 has degree 3, 1 has degree 5, and 1 has degree 6. Okay, so if I add this up here, I get 22 total. Okay. Now, from the statement, it says that in a graph, the sum of the degrees of the vertices, which is 22, equals twice the number of edges. Okay, so 22 divided by 2 would give me, there's 11 edges in this graph. And I have no idea what this graph looks like, but I know that there's 11 edges there. Okay. Problem 8 says that there are 7 people at a meeting. One of these shakes hands with 4 people, 4 shake hands with 2 people, and 2 shake hands with 3 people. How many handshakes occur? Okay, well, as a hint, we're going to use the fact that the sum of the degrees of the vertices in a graph is twice the number of edges. Okay, so let me add up the sum of the degrees there. Okay, so one of the shakes with 4 people, 4 shake hands with 2 people. Okay, so there's 4 twos, and 2 shake hands with 3 people. Okay, so there's so if I add up these numbers here, I get 18. 18 is the total. Okay. So from the statement above, problem 7, if I divide 18 by 2, there'd be 9 edges. Okay, so in this problem, how many handshakes would there be? Well, I've just used the hint. Okay, use the fact that the sum of the degrees of the vertices in a graph is twice the number of edges. Okay, so there'd be 9 handshakes that would occur in this graph. Part B says to draw a graph to model the situation and check it using your answer to part A. Okay, so here would be one answer that you could give. There are other answers that you could give, so vertex A has 4 edges joining it. Vertex B has 3 edges joining it. Vertex C has 2. Vertex D has 2. Vertex E has 3. Okay, vertex F has 2, and vertex G has 2. Okay, and if you were to count the number of edges here, there'd be 9 total. So there'd be 9 handshakes that took place. Okay. I'm going to go ahead and stop right here in the video, and now we're still in section 14.1. So in the next video, we'll do some more 14.1.